exam status. Okay, so all right. So I hope y'all have been keeping up with the problems, because if you don't, everything is creeping up on you. So this is the problem, first problem I'm going to work. It's already worked in your notes, but I'm just going to go through the process and explain it. And it says a car that's low to have a total mass of 100 kilograms, center of mass at G, where G is right here, and a force of P of 100 newtons is applied to the handle, which is up here. And it says neglect the mass of the wheels and compute the normal reactions at each of the two wheels, A and B. So the first thing that you have to do in a situation like this, and so if you go all the way back to chapter 13, because this is basically, I have stated over and over that we keep repeating the same things over and over until we built up to this point where we are looking at the effects of geometry on motion. And so I talked to you at that time about kinetic diagrams, and I said the sum of the forces equals ma. And so at the time, just to refresh your memory, I wrote the equation that sum of the forces is equal to the mass times acceleration. Well, what this is saying is that the free body diagram could be F1, this could be F2, this is the resultant force, and this is equal to mass times acceleration. Okay, and so if you recall how we talked about all this in chapter 13, is that the acceleration is in the same direction as the resultant unbalanced force. Okay, so all that having been said, let's work the problem. So for those of you who are aerospace engineering majors, and who are signed up for vibrations this summer, I'm going to take into account that we did not get into chapter 17, section 4, which is rotation about a fixed axis. And so I will take that time to teach you that this summer at the beginning of vibrations. However, if you go on and if you wait till the fall to take vibrations, Keshvan will probably not afford you that luxury. So just saying. All right. So let's get going with this. So we have this cart, and we have a force that is being pushed on this cart. This relationship here is a 3, 4, 5, and it is a 100 Newton unbalanced force. So I'm not going to draw the wheels, but we have a normal force here, and we have a normal force here. So this is the normal force at B, and this is normal force at A. And so up here somewhere, we have the weight, and because the weight passes through the center of mass, so this is point G, it's 100 kilograms, so if you multiply that by 9.81 meters per second squared, we get 981 newtons. And so I'm not going to take all the time to draw all the dimensions and everything on here, because you have them in your notes. And so the sum of the forces is equal to the mass times acceleration. And so this thing is going to move to the right. And so we are asked to find what the normal forces are at A and B. And so if we sum the forces in the x direction, so you only have 3 equations. And what I always tell the students is just apply all 3 equations, take what it gives you. The worst case scenario, 3 equations, 3 unknowns. Usually sometimes it's not even that. So, but you apply all 3, do what you have to do, and the answers will fall out of them. And so if we sum the forces in the x direction equal to the mass times acceleration of the center of mass in the x direction, we get the following equation. We have 100 times 4/5, which is the x component of that force, is equal to the mass, which is 100, times the acceleration of the center of mass in the x direction. And so when you solve for the acceleration of the center of mass in the x direction, it's equal to 0.8 meters per second squared.
Here we go.
All right. So now we need to sum the forces in the y direction. So if we sum the forces in the y direction equal to the mass times acceleration of center of mass in the y direction, we have the normal force at A plus the normal force at B plus, minus 981 minus 100 times 3/5 is equal to 0. And the reason it's equal to 0 is because there is no motion in the y direction. So the acceleration in the y direction is 0. So when you simplify this equation, you get that the normal force at A plus the normal force at B is equal to 1,041. All right. And so we have one equation, two unknowns. So you can see what's about to happen. When we sum the moments about the center of mass and set that equal to I alpha, we'll have another equation with two unknowns, and we'll have two equations, two unknowns, we can solve it. So therefore, if we sum the moments about point G, we're going to sum the moments about the center of mass. And when we sum the moments about the center of mass, we're going to assume this direction to be positive. And so when we sum the moments about the center of mass, this 981 force has Newton force has no moment about that point. So this is equal to the mass moment of inertia about point G. See here, these 2 points better match. Because if I sum the moments about B and I set that equal to the mass moment of inertia about G, I just violated the laws of physics, okay? And so we multiply this by the angular acceleration. However, this thing is not rotating. It's simply translating to the right. So this goes to 0. And so I have the normal force at A times 0.6 minus 0.4 times the normal force at B plus 100 times 3/5. This is the vertical component of this force times 0.7 minus 100 times 4/5, which is the horizontal component. It has a negative moment, and then the distance between the center of mass and the horizontal component of this force is here. This is going to be 1.2 minus 0.5, and this is equal to 0. And so I come up with a second equation that says that 0.6 times the normal force at A minus 0.4 times the normal force at B is equal to 14. And so this is equation 2. This is equation 1. So then when you solve these two equations, you have the normal force at A is equal to 430 newtons, and the normal force at B is equal to 611 newtons. However, there are actually 4 wheels on this cart, and what I found was that this is the normal force at A. So if I had said what is the actual force on each wheel, since there are 4 wheels, I would have had to divide this by 2. And so on each wheel, then at A, it would be 215 newtons. And the normal force at B would be 305.5. Okay. And so that would be the normal force on each wheel. Any questions about that? Cool deal.
Can you explain why you divide the forces again at the end?
Okay. What we found was a normal force at A and a normal force at B. There are actually 4 tires. We found the total force acting up back here and here. But since there are 4 tires, you have to divide, or 4 wheels, you have to divide that by 2. Like your car. Your car has 4 wheels. We found the total normal force on the rear of the car and the total normal force on the front of the car. But since there are 4 tires on your car, we divide by 2. You get it?
Yeah.
Okay. All right. Any other questions? Wow. This is going to go easy today. All right. And I'll put your, I don't think I've put your suggested problems out there, but I'll put those out there today. And then basically Wednesday, Friday will be used for any questions you might have. Monday's your exam, so keep that in mind as you go through, throughout this week. All right. So the second problem is a truck with a desk in the back of it. And the this desk or table has a mass of 100 kilograms, and it gives its center of mass location. It says that the coefficient of static friction between the legs of the table and the bed of the truck is 0.2, and that's a coefficient of static friction. So it says compute the maximum acceleration of the truck possible without causing the table to move relative to the truck and the corresponding normal reactions on the legs at A and B. All right. So the free body diagram is included in the notes, and so I'm not going to go through all that process. And when you can simply sit there and look at it. And so, but I am going to work through the equations of motion and explain each one. All right. So what we're trying to find is the acceleration that the truck can maintain without the desk sliding relative to the truck. All right. So if we sum the forces in the x direction and set that equal to the mass times acceleration of the center of mass in the x direction, there are frictional forces that are acting on each of the legs. And so the thing is, which way is the friction acting? Because if the truck is going this way, the motion of the desk wants to go this way, so therefore friction has to point forward. All right, because friction always opposes motion. And so I have 0.2 times the normal force at A, which is the coefficient of friction times the normal force at A, plus 0.2 times the normal force at B is equal to the mass, which is 100 times the acceleration of mass in the x direction. All right, so we have one equation, 3 unknowns. So if we sum the forces in the y direction equal to the mass times acceleration of the center of mass in the y direction, there is no motion in the y direction, so this goes to 0. So we get that the normal force at A plus the normal force at B is equal to 981. One equation, 2 unknowns. So we need a third equation to help us out. And so if we sum the moments about the center of mass and set that equal to the mass moment of inertia about the center of mass, again, same point, okay, and this is times alpha. So, but this desk is not rotating, so that goes to 0. So when we write this equation, we get 0.2 times the normal force at B. I'm assuming moments in that direction to be positive, times 0.75 plus 0.2 times the normal force at A times 0.75 plus 0.9 times the normal force at A minus the normal force at B times 0.6. And this is equal to 0. And so these are the moments due to the frictional forces, and these are the moments due to the normal forces. And so when you simplify this equation, you have negative 0.45 times the normal force at B plus 1.05 times the normal force at A is equal to 0. So now what I have here and here, I have two equations, two unknowns. Okay, so I can solve these two equations. When I do, I get that the normal force at A is equal to 294 newtons. Normal force at B is equal to 686.7 newtons. And you can see that as the truck accelerates, this desk wants to rotate, and so most of the normal force is being transmitted to the back legs. That's the reason why if you ever haul furniture and you do some kind of drastic maneuver, the legs, they're at your furniture in the back of your truck, the legs that are at the rear, a lot of times are the ones that get damaged. And I've actually done that to my own furniture before. And so when you plug these two values into this equation right here, you get that the acceleration of the center of mass in the x direction, or the truck, is equal to 1.96 meters per second squared.
Will we always choose G to sum the moments around?
It depends. You may not even be given the center of mass in location. Don't ever try it. Please don't ever try and pin me into an always statement, because I'm never going to answer the question. Because no, you don't always do anything. And so what you are to do is to look at the problem, and you have to understand that's part of being an engineer. You have to look at the problem and decide on a methodology or a solution sequence to solve the problem. And that's the very problem that my mechanics and material students had, because I worked one problem and I explained that something was true, and about 30 or 40 students said that it was true all the time, and it's not. So
okay, in what situation would it be advantageous to choose G?
if it's given, maybe, I don't know.
Okay.
I may give you a problem that is not given. And so then you would what would you do? You'd sum the moments about some point. Like one of the suggested problems, I believe, if I'm not mistaken, has a forklift in it. And I don't think the center of mass location is given. And so then what you have to do in that problem is you have to sum the moments about any point, and you have to set that equal to the summation of the kinetic moments about that point.
Okay.
So any more questions? All right. Well, your test is a week from today. This is all the material. And so if you haven't started the problems, you should. And formulate your questions, because your test will be a week from today. It will be Monday morning at 9 a.m. And so since there are no more questions, this is all for today, and I hope you all have a wonderful day.
I have a question, not regarding dynamics, if you don't mind, really quick. On the mechanics and materials, it says did not use paper from Canvas.
That's right.
What paper were you referring to?
Apparently, you don't read anything I send you. You don't read emails. You don't read the exam guidelines I sent. You don't tune into the Zoom meetings. I don't know what you've been doing, but it was all clearly explained, and it's going to be there for dynamics too. So there was paper on Canvas. I uploaded, and I told y'all to use it.
All right. Thanks for the attitude.
Oh, you're welcome.